Okay, so let's start the class. I want to begin with the following problem. The integral of 1 over 1 minus x. Okay. We know that this is actually the antiderivative of this function is the inverse of hyperbolic tangent x. Okay. But on the other hand, the inverse of hyperbolic tangent x is going to be this function. There is another elementary expressions for the inverse hyperbolic tangent x. Now we can get this answer directly using the ideas. Using the ideas of, see, we know that use a substitution, right? 1 over x dx is going to be natural log of absolute x plus constant. Okay? Right? So, more general, you have a constant, then just replace x by x minus k, or plus k, doesn't matter. Okay. Now, this function, 1 over 1 minus x, can be separate as this, okay, and divide by 2. But how do you know that, right? I just by guessing trying, okay? We are going to learn more general methods to how to express them as a sum of the reciprocal linear functions, okay? So you add them together, the denominator is 1 minus x squared, the numerator with 1 plus x plus 1 minus x. Then cancel out, you get 2, so you can divide by 2. Okay, and then you can also express it in the following form: x 1 plus x, okay, minus. I'm going to change the sign. So the reason I want to do that becoming using the above formula. Okay, so the integral of this function is going to be integral of x plus 1 dx minus half of the integral of x minus 1 dx. So we can use above formula. I can quickly get x plus 1 and minus natural log of x minus 1 plus constant. Okay, so first of all, we have absolute value symbol there. Then I can put them together. I get x plus 1 and x minus 1 plus constant. Since it's inside the absolute value, you can change it to x 1 plus x, 1 minus x. It's the same. Okay, no difference. But if x is smaller than 1, this whole fraction is positive. So you can simply write 1 plus x, 1 minus x plus constant. Here we put the restriction on x. Okay. Otherwise, if x is larger than 1, then this is not true. Okay, so we assume that. So you can also have an expression without absolute symbol if you assume absolute x is less than 1. Right, so this is a good example to start with. Right. Now, we can use this to solve other problems. For example, if you have dx, for example, 5, plus x minus x squared dx. Something like that. Okay. I can make it easier. Just put a 2 here. Okay, 2x. Yeah. All right. So how can I solve this problem? Yeah, let's look at 5 plus 2x minus x squared. If you want to take a negative sign out, you get x squared minus 2x here, right? So you have two terms containing x. I don't like this, right? It's called a completing square. Plus 1 minus 1, okay? Right? Then you have x minus 1 square minus 1, but when you get rid of the parentheses, you get 6 minus x minus 1 square. Okay, that's what we want. Okay, you can also take 6 out. If you take 6 out, it could be 1 minus x minus 1 divided by square of 6 squared. Okay, why we have to do that? Because we're going to use above result to evaluate the integral. So now we have the integral, okay, and denominate, you take 6 out, right? So 1 over 6. Okay, it looks like 1 minus x squared. So what you have to do is you let u to be x minus 1 square of 6. You can do like that, okay? Then du equals 1 over square of 6 dx. Okay, so this integral is 1 minus u squared, and the dx is a square of 6 du. You see, it is very simple right now. Okay, then you use above formula. We assume x. Yeah, if you don't want to assume absolute of u is less than 1, then you use put absolute value symbol there. It's 1 plus u, 1 minus u, plus constant. Okay. Then 1 plus x minus 1 square of 6, 1 minus x minus 1 square of 6. Okay, this is the answer. Now, if you do not take 6 out, then when you use a substitution, you have to use, it still involves radicals, okay? So, but anyways, the idea is to simplify the integral to 1 over 1 minus u squared. For polynomials, there always can, every polynomial, ax plus bx plus c, can be always expressed in the form like that, x plus b over 2a square and plus c minus b square 4a. Okay, so it can be always written in that form. This is where we quadratic formula from. You know, how to get a quadratic formula. You know, you use that from middle school. But this is the way how to get a quadratic formula. And you combine them together, okay? And then you put the minus here, 4a, b squared minus 4ac, okay? Are you familiar with that, right? So if you set this to be 0, then how do you solve the problem, right? b over 2a is going to be square, right? And this side is right? Then you divide both sides by a, and you get 4a squared b squared minus 4ac. And this, you're familiar with that. Then you put then you get a quadratic formula. Plus minus, and the square root of 4a is just 2a, right? And b squared minus 4ac. So this is a quadratic formula. Quadratic formula for the roots of a quadratic equation. Okay. So anyway, we only use the first part. We always think, every term can be expressed in this form. So either it's minus or plus. So we can evaluate the integral. We need another integrals. Okay. We know integral of 1 plus x squared. Right? We did a 1 minus x squared. 1 plus x squared. What is this? This is just the arctangent x plus constant. So remember, right? 1 minus x squared dx is hyperbolic tangent x plus c. So there's a small difference. I put the h here, right? Okay. If we know those two integrals, of course, I have another expression for this, half of natural log absolute root of 1 plus x, 1 minus x, okay? And then, yeah, there's another version for that, okay? But for the arctangent x, I don't have. All right, so those are the two basic integrals. If you know that, then you can evaluate the integral of any quadratic function, one of the quadratic function, okay? I just randomly write down the problem, like x squared plus 3 plus 4x plus, let's say plus 6 dx, okay? Okay. So what I'm going to do, I think the leading coefficient here is x squared. So x squared plus 4x plus 6, I can separate, right? X squared plus 4x, I think I should plus 4 here. Then I only have a 2. Okay, great. It's called completing square. So this will be x plus 2 squared plus 2. So it looks like 1 plus x squared type. Okay, so then I put the integral. I'm going to rewrite this integral. It's going to be right. Okay, so then you have to use a substitution to change it to the above form. Okay, so substitution you can let u to be. I think I need a square of 2 here because I really want to get rid of. Nope, that's opposite the way. Yeah. I'm going to change x plus 2 to be square root 2 times u. How about like that? Okay. So u is going to be square of x plus 2 divided by square root 2 because when x plus 2 equals square root 2u, then when you square, you get the same effect. That's 2 plus 2u squared, right? Then your 2 can be taken out. And what is dx? Dx is square root 2 du, right? All right, so after you simplify a little bit, you get the simplest form of the integral. Then you already know the answer for that. Okay, so that is going to be square root 2 arctangent to u plus constant. And what is u? And you solve that. All right, that. So we get an idea, right? So now, one of any quadratic functions, we are able to solve it. We can change by substitution by completing square. We change the integral to be one of the above 2 simple integrals. Okay, So how about x squared minus 2x minus 3? Okay. Okay, let me say a few words. So 1 minus x squared dx, right? Is going to be nature log of absolute 1 plus x, 1 minus x plus c. Now, if you change the sign, x squared minus 1 dx is the same. You just put a negative sign in front of that, then you have a, you just turn this upside down. There's no bigger essential difference here. Okay, if you put a negative sign in front of that, and then you put a negative sign in front of both sides, and then you have negative power, right? Negative 1, then you turn this upside. It's the same. Okay, but here x squared minus 1 looks like x should be greater than 1, right? Those two are the same, essentially the same identity. Okay. All right, so let's look at the x squared minus 2x minus 3. I know x squared minus 2x plus 1 can form a square. And then I have to minus 4 because I want to get negative 3. We make, we change the negative 3 to positive 1 minus 3. Okay, then you get x minus 1 squared minus 4. So this will be the type like x squared minus 1 type, right? All right, so now the integral becomes become this. All right, now I'm going to use a substitution. I want to get like something square minus 1. Here's minus 4. So I let x minus 1 equals 2u, okay? So then you get 2u squared before u squared, then you have same 4, you can take it out. So this will be 4u squared minus 4. And the dx is just 2 du, okay? Then you take 4 out, you get and you know the formula for that, right? Is it is going to be half of natural log, 1 minus u over 1 plus u and plus constant. Then you separate, what is u here? Okay, it will be, take 2 out, there's 2 on the top, that's 4. 2 over 4 is 1 over 2. So 1 minus half of x minus 1, 1 plus half of x minus 1. And then you simplify it. When you simplify, 2 cancel out. 2 minus x minus 1, 2 plus x minus 1 plus constant. Right? And then you simplify 2, it's actually 3 minus. I have a, I have a 2, no, I have a 4 here. Yeah, that's the 4. That's the 4 is missing. Because I already have a 1/2 here, then I get another 1/2. Right? So this is going to be 3 minus x, 1 plus x, and plus constant. All right. Since it's inside the parenthesis, inside the absolute value symbol, you can change the x, 3 minus x, the same as like x minus 3. Okay, so this is the answer. So here we use a formula. We already know the formula. We use a formula, the integral of 1 over x squared minus 1. If you don't use that formula, what you can do x squared minus 2x minus 3, something made me realize that this can be even factored out. Okay, this can be factored out. Okay, you don't need to write this like something square minus 4. This is it's a product, two factors. Can we use that one to solve the problem? The answer is yes. Okay, so if you put in the denominator, you get x minus 3, x plus 1. Can you separate them? Okay, a plus or minus, I think usually it's minus, because I want to get rid of x. When you combine those two terms, I get 4. So I have to divide by 4. This is how do I quickly decompose it into the sum of two reciprocals of linear functions. Okay, so this is the idea. You know, first of all, you think maybe it can be written as a difference of two terms. Then you combine them together. Oh, I create. You know, there's a 4 in the numerator, so I have to divide by 4 in order to make them equal. Okay. Then you get the integral of the first term minus the integral of the second term. So actually what we're doing here is repeating the same procedure for the integral of x1 minus x squared, or x squared minus 1. Okay, but it's here slight, you know, the linear term is slightly different. So you get natural log absolute of x minus 3 minus natural log of absolute of x plus 1 and plus constant. Then you can put them together. Here's x minus 3, here's x plus 1 plus constant, and you get the same result. Exact same result. Okay, so for polynomials, for some quadratic function, reciprocal quadratic functions, you can have two different ways to solve the problem. Okay. The first one is use the formula we just learned here. Use these formulas. Okay. So how to get this formula? We use the idea, just decompose the function into two parts. That's the same idea, right? And then you use that formula, just use substitution. Okay. Or you can directly decompose the function, then you evaluate the integral. Okay. Decompose the function here. Right? This is a part. Then you evaluate the integral. Now, if I change the function -3 to +3, right? That's small change, but we totally different ideas. You are not able to factor x squared minus 4a. I think so. Yeah. So x squared minus 2x plus 3 does not have a 0. That's b squared minus 4x. B squared, let's see. Do we get a yeah. Yeah. See, this is going to be x squared minus 2x plus 1 and the plus 2, right? So this one has no 0. It's always positive. This never be 0. So it's have no zeros. All right, the reason is it's a b squared minus 4ac is negative. Okay. But that's good enough, you know, for us to evaluate the integral. So you get x minus 1 squared plus 2 dx, right? And I cannot decompose since I cannot write x squared minus 2x plus 3 as a product of two linear factors, I'm not able to decompose these fractions into the sum of two fractions, of simple fractions. So what I have to do is here use the same, use substitution. Let x minus 1 to be square root 2u again. Okay, so this integral here is a square root 2u squared plus 2, and the dx is a square root 2 du. Okay, then you simplified the square root 2 over 2, right? Then you get u squared plus 1 du. All right. Then we have the formula, the inverse of tangent of u plus constant. And that is going to be x minus 1 square root 2 plus constant. Right, it's the same result. Right. But now we are going to deal with a little bit more general problems. I still use this, okay? X squared minus 2x minus over here x plus 2 dx. I changed the numerator from 1 to x plus 2. How can we do this problem? I'm going to show you two different ways to solve this problem. Yeah. Okay. First of all, let's use a substitution. Okay. So we already know that it's going to be x squared minus 2x plus 1 minus 1, so it's going to be minus 4, right? We already did this. Okay, good. I tried to make the denominator simple. So I will get the integral of x plus 2, x minus 1 squared minus 4 dx. Okay, so it's a very natural idea. You let this to be 2u, okay? So then you get 4u squared. That's fine. So the integral becomes 4u squared minus 4, and the dx is 2 du, right? And how about x plus 2? Well, x minus 1 equals 2u. So x equals 2u plus 1. X plus 2 is 2u plus 3. Okay, so 2u plus 3, that's fine. Right, no problem. All right, so now you will get 2 canceled out. I get the 1/2 integral of u squared minus 1, 2u plus 3 du, right? What is next? I still have something in the numerator, but that's fine. Okay, I can separate. I do get 1/2 2u squared minus 1 du. Then I got 3/2 integral of u squared minus 1 du. Okay. The first one, you can use substitution quickly. Okay, 2u over u squared minus 1 can be evaluated quickly using standard substitution. Right? Why? Because you can let w to be u squared minus 1. Then dw is going to be 2u du, right? So that part is going to be just a dw over w, okay? And the other one, I needed to use a substitute, needed a formula, okay? So integral of 1 over u squared minus 1, okay? I know it's 1 minus u squared is a natural log. I think 1 plus u is on the top. 1 minus u at the bottom. Okay. Yeah, you go back to check it's u squared. Hold on. One is no, this minus is plus is on the top. Yeah. Yeah, plus is on the top, minus at the bottom because u squared first. All right. So W is nature of W, right? And it's absolute value of W and plus 304. All right, so what is W? W is u squared minus 1. All right, then you have to go back. What is u? U is x minus 1 divided by 2. Okay, you have to repress it. If you don't have time, just say where u is going to be x minus 1 divided by 2. Okay, otherwise you have to put this back. This is going to be x minus 1 over 2 squared minus 1 plus 3 over 4 nature log. We have absolute value here. It's 1 minus 1 plus and plus constant. You may simplify it. So x squared, yeah, if we simplify this part, you get x squared minus 2x plus 1 minus 4 is actually minus 3 divided by 4. Because the 4 is a constant, you can move out. So it's going to be half of a nature log, x squared minus 2x minus 3. And here, nature log. And this will be 2 minus x minus 1, 2 plus x minus 1. So actually, it's going to be 3 minus x. And the same, this is 1 plus x. Okay. And this will be another constant, so not the same constant. Well, so we have additional terms down there. How do you, if you increase, let me just look at this problem. X squared minus 1 over x squared. Make it simple, just x squared. Okay. So that I already simplified the denominator, just x squared minus 1. Okay. If without x squared in the numerator, I know this is a formula, right? It's going to be, x plus x minus 1, 1 minus x, 1 plus x plus constant. Okay. Okay. If you're not sure, double check it. Remove the absolute, very simple. And you differentiate. You forget the sign. Just differentiate the right-hand side to if you see you can get 1 over x squared minus 1. Sometimes you're not sure which one is on the top, which is at the bottom. Then you just find the derivative. Okay? And you will get, I think, you will get x squared minus 1 over x squared minus 1. That's correct. So if I continue to increase the power of the numerator, what is the next step? Well, there's a quick way to do it. Is x squared minus x squared is going to be x squared minus 1 plus 1. That sounds trivial, but it's not easy to get. Okay. So it's going to be x squared minus 1 plus 1, x squared minus 1, then this part will be 1. Then change it to a very simple function. Right? So then the integral of x squared minus 1 dx is just integral of 1 plus x squared minus 1 dx. So the first one we give the x, the second one is given half of the natural log, 1 minus x, 1 plus x, plus constant. So it only takes a few seconds you can write an answer. But if then you say, oh, because just x squared on the top, how about x squared plus 3x? Okay. In that case, you can also quickly decompose. You can quickly express it in the form like x squared, right? X squared minus 1 dx plus 3x over x squared minus 1 dx. The second part to use is substitution. This is the sustained substitution. Whenever there's x squared, here's x, you can use substitution. Let the w to be x squared minus 1. The first part we just did it, right? X squared, right? You can have minus 1 plus 1. Okay. So actually you get this is a 1 plus 1 over x squared minus 1, right? And dx plus 3, and here's x squared minus 1 dx. Okay, this part you have to use substitution, the last part. The first part you already know the answer. Okay, so here you have to use a substitution, w equal to x squared minus 1, dw equals 2x dx. Okay, so the integral of x over x squared minus dx is going to be half of dw over w. Okay, which is going to be half of natural log of 3w plus constant. So this is the idea. Okay. So now we can get the answer. Here's x, half of the natural log of 1 minus x, 1 plus x, and plus this 3 over 2 natural log. W is x squared minus 1 and plus constant. That's it. You can also decompose it in a more standard way. If the degree of the numerator is greater than or equal to the degree of the denominator, you can use a long division to simplify. Okay, this is a long division. So x squared plus 3x divided by x squared minus 1. Okay. When you divide polynomial by another polynomial, and you get just put the 1 here, so you get x squared minus 1. You do the subtraction, you get 3x plus 1. That's the denominator. Now, what does that mean? You have the quotient. Quotient is 1. You have the remainder, 3x plus 1. So in other words, x squared plus 3x divided by x squared minus 1 is quotient is 1. It's going to be 3x plus 1 and x squared minus 1. Okay. Then the standard method tells you have to separate the two terms. So it's 1 plus 3x over x squared minus 1 plus 1 over x squared minus 1. Okay. Then you can evaluate each of the integrals to solve the problem. Okay, so let's do the next problem. So how about this? X squared plus 4, x plus 2 squared dx. Okay. You can use a long division to simplify a little bit. That's a pretty standard way to do. Or you can play some tricks to decompose it. So I like, yeah, if you're very good in algebra, then you can do it. So it's x squared plus 4x plus 4, right? And then it's easy to see that x squared plus 4, it shows up in the denominator. So you give me x squared plus 4 and plus 4x. Okay? Then what do you get? You get the 1 plus 4x over x squared plus 4. Okay. But you can also get this from a long division. Okay? You can get the quotient equals 1, the remainder is 4x. But right now, suppose we have this, right? So the integral is going to be integral of 1 plus 4x x squared plus 4 dx. So I'm going to separate this too. So the first one is just x. The second one I need a substitution because you see, whenever you see x squared in the denominator, then there's x in the numerator, you can use substitution. So it's a pretty standard substitution. Right, then dw equals 2x dx. All right, so the first term is x. The second term, I change it to the substitution, it's w. And I think it's 2 dw. Okay, for 2x dx is dw, so 4x dx is 2 dw. Then you have this, okay? You can move to inside. That's 10w squared. You can simply write w squared. Then you don't need a absolute very simple because w squared is always positive. Okay. So what is the x? What's the w? W is x squared plus 4, then square. So this is the answer. Right. As you can see that. I want to put something in the numerator. Okay. I can say x plus, let's say x plus 4 dx. There are several ways to solve this problem. The key idea is to change decompose the function to several pieces, and each piece you can figure out how to solve it, right? So I'm going to show you a couple ways to do it. So there are x squared minus, right? X squared minus x minus 6, right? This can be written as x minus 3, x plus 2. No problem. Negative 3x plus 2x and negative x, okay? But this also can be written as x squared minus x. To complete the square, I have to put a quarter here, okay? And subtract a quarter. Okay, why I have to divide by? Because there's only negative x there. So you get x minus 1/2 squared. And here is a 4/25. Okay. Yeah. So it's 25 because 6 plus a quarter. How did I get a negative?
No, I just couldn't read it.
Oh, that's 25. Yeah, 25, 6 plus a quarter is going to be 24 plus 1 is 25. It's a perfect square. Great. All right, so for that polynomial, you have two forms to describe. Then it's depends on which way you go. Okay. So if you go, if you use a complete square, then that's possible. Why not, right? So this is the integral of x plus 4. Then here's x minus quarter. Here's 25 over 4 dx. Okay, if you use this form, you can solve the problem. Okay, so how can I do? I use substitution. Let u to be, I'm going to, yeah. Actually, what we do is we want to get rid of we want to get u squared minus 1. So what I'm going to do is x minus 1/2 should be equal to 5 over 2u, right? How about like that? Then when you square it, they get 25 over 4. Okay, so the integral is going to be 25 over 4u squared minus 25 over 4. Great. And the dx is just 5 over 2 du. How about x plus 4? X plus 4 is going to be 2 over 5u plus 1/2 plus 4. Okay? And that is also good because it's going to be 9 over 2. So 5 over 2u plus 9 over 2. Not too bad. Okay? You can take, you can take a 5 over 2 out. Right? So let's take a 5 over 2 out. 5 over 2, it's going to be 25 over 4. That's the numerator, okay? Let's simplify, okay? You know how to simplify, right? Let me check. Yeah, you take 25 out, 25 over 4 out, you get u squared minus 1, okay? How about the numerator? You have 125 here, another 25 there. 5 over 2 squared will be 25 over 2. So I think if I take this out, that'll be 9 over 5 du. Okay. That's it. You take a 5 over 2 out from the numerator, and together with another 5 over 2, you get 25 over 4 that cancel out. Okay. Then you separate the integral into two parts. And for the second one, you have a formula. For the first one, you use another substitution. Okay? For the second one, you get another substitution. If you use a w to be u squared minus 1, and dw equals 2u du. So I need 1/2 dw over w. And here, 9 over 4 is going to be half of natural log 1 minus u over 1 plus u plus constant. Okay. Yes, there's a plus constant. So w is going to be, natural log w is going to be u squared minus 1, okay? And then here's 9 over 10 natural log 1 minus u 1 plus u. And what is u? I think that u already is given, where u is going to be 2 over 5x minus 1, I think, yeah. X minus 1/2. Okay. So just plug them into the formula, you get the answer. Okay. Now, are there other ways to do, right? So we know that x squared minus x minus, yeah, let's go back to this problem. Here's x plus 4, x squared minus x minus 6dx, right? I know x squared minus x minus 6 is x minus 3, x plus 2. I hope I can decompose it into some form. But I don't expect to have the same constant. Right. Those two constants to be determined later. Okay. All right, so how to do that? You combine them again. I get ax plus 2 plus bx minus 3. I put them together, I get a plus b x, and here's 2a minus 3b. And I compare the coefficients on both sides. I see that x plus b should be 1. A plus b should be equal 1. 2a minus 3b should be equal to 4. And I'm pretty sure that can be, you can solve for a and b. Okay. Now, if you, yeah, this is equation 1, equation 2, then how do you solve them? I think equation 1 multiplied by 2. Okay. Then 2a minus 3b equals 4. Add them together, you will get, do subtraction. Okay. It's an equation 1 prime because it's modified. Equation 1 prime minus equation 2, you get 5b equals negative 2. So b is going to be negative 2 over 5. Yeah, negative b 2 over 5. Okay. Then once you get b, then you can get a. Again, a is 1 minus b. So 1 plus 2 over 5, it's a 7 over 5. So you get two constants. And but good part is you can always decompose it in the following form. Okay. So you can you can decompose this function into the sum of these two functions. And then we know how to evaluate the integral of each, right? Each fact. So I get 5 over 7 over 5 integral of x minus 3 dx. And here's 2 over 5 integral of x plus 2 dx. And here's it's a linear factor in the denominator. So you can put natural log absolute x minus 3. I think the first method is better. Right? Yeah, if you're able to decompose. Now, if the power of the numerator is larger than or greater than or equal to the power of the denominator, you have to use the long division first. Right? Otherwise, you cannot decompose it into two functions. Yeah, so we go back to what we did here. We find out we handle this, right? I did not even simplify it. I'm pretty sure if we did not make any mistakes, we are able to simplify to the terms we want. Okay, but this method is also natural, but you have to decompose. You have to use substitution. Okay, and you end up with in functions like that. It's not too bad, right? Okay. So if the denominator is a quadratic function, the numerator is a linear term or polynomial, another polynomial. If it's polynomial, you have to use a long division to reduce the power of the polynomial. Then you have, yeah. So let me summarize that. If we have a x squared plus bx plus c, and here's another polynomial, okay? Then you can always put divided by long division, and then you get another one, c dx plus e. Okay, so this is the first step you can try, and then it's up to you, and it also depends on what type of function is the denominator. Okay, if you cannot factor it, then you just use a substitution. Okay, then just use substitution. So there are two types of them. You can, if you can factor it, then you have two options. Okay, so if ax squared plus bx plus c equals, you can factor it, x minus r1, x minus r2. Okay, in that case, then dx plus e, x minus r1, x minus r2 can be separate like this. And then if you determine the coefficients, then you can solve the problem. Okay, but you can all, in that case, you can also express it in the form like x minus h squared plus h is minus k. Okay, and k is positive in that case. So in that case, then you use another substitution to solve the problem, because dx plus e ax, if you use this method, then you don't decompose it. Okay, what you do is you will get dx minus h and ax minus h squared minus k, and then e, I think it's plus dh. So you rewrite this, okay? And then you use a substitution to change it to something like au plus b and u squared minus 1, something like that, okay? Use a substitution, okay? So there are two different ways to solve the problem if the denominator has two rows. If the denominator do not have two rows, that means you have x plus h minus h squared plus k, k is positive. Then the only way you can do is dx plus e and a x minus h squared plus k. The only way you can do is use a substitution. You can get au plus b and u squared plus 1, okay? So you know how to evaluate this integral, okay? Use substitution, okay? Eventually you can get that. What kind of substitution you can do? I think here's a, b, no, I assume A is always positive, okay? A, B, A, and K are in the same sign, okay? So then square root A, x minus h should be equal to u, okay? And this one, the substitution you're using, and here we're using square root A, x minus h equals u, okay? So you can eventually, you can simplify the integral. So I summarize this two type of integrals. For the first one, you have two options, and we did a tweak. We did the same. We solved this. We evaluate integral in two different ways. Okay. And I prefer the first one, decompose the function directly into two linear, two terms, then you determine the coefficients capital A and capital B. Okay. For the second one, you cannot decompose a function because u squared plus 1 cannot be factored out. Okay. That's all about today's lecture.